Okay, I'll start today's lecture right now. So today we're going to be talking about molar mass and moles calculation. So today would be kind of a heavy math day for our chemistry lecture today. So for the homework last week, you guys did well. The class range was a 5 to 6 out of 6. That means you guys really understood the material really well. And you guys did a great job. So for this week, there's going to be 6 questions for today's homework, and I would encourage you guys all to try to attempt those. And as always, I'll give written feedback and post your grade on Google Classroom. And today, this lecture is kind of math intensive. I would suggest a calculator, or if you don't have one, to maybe use a phone or like an iPad or something. The calculations today are quite hard to do in your head. And if you have any questions during this lecture, I know it could be kind of difficult, so please post them to the private PM me in the private chat, and I'll try to answer them if you're confused. And as always, you can contact me by email if you have any suggestions to improve this course. And I also will post a Google Forms suggestion about this course next in a few hours, I believe. And this will be on Google Classroom, and it's under the assignments tab. And there's 7 questions, and it's basically about suggestions about this class as a whole. And if we want to do like a part 2 of this class in the future, and there's like 7 questions, and it should only take around 2 to 4 minutes. And I'll appreciate it if you would fill that out by the end of next week. So today we're going to do a review of moles and molar mass. And then we're going to find the mass of an individual molecule. And then at the very end, we're going to do conversion between moles and grams. So that's what we're going to be doing today. So we're going to first review moles and molar mass. So you might be wondering, we've covered this in like 2 lectures ago, the rationale of using moles. So when chemists prepare a compound in either an industry or the lab, there's usually a lot of molecules. So if we have like 10 grams of ethanol, which is about the same mass as 10 paper clips, we have around 1.31 times 10 to the 23rd molecules of ethanol. And that's a humongous number, and chemists can't really think in that large scale. So it'll be easier if we can have a smaller unit that we can compare numbers across. So chemists have discovered the concepts of moles to deal with the enormous amount of molecules in the sample. So that's why chemists have invented moles. And remember, a mole is a fixed constant, which has a value of 6.02 times 10 to the 23rd. We can just simplify this and approximate 6.02 times 10 to the 23rd. And that's the value we're going to be using today in class. So we don't have to carry that many digits, but this is the exact digits, but we can approximate with 6.02 times 10 to the 23rd. So 1 mole of any substance is just 6.02 times 10 to the 23rd molecules of that substance. So for example, 1 mole of gold is 6.02 times 10 to the 23rd gold atoms. You can also use it for 1 mole of dogs, and you'll have 6.02 times 10 to the 23rd dogs, which would be a large amount of dogs. So this can be anything, a mole. You can have any molecule, atom, etc., ranging from golds to dogs. Remember, a mole is just a number, just like how a dozen eggs is 12 eggs, a dozen tires is 12 tires. A mole is similar, and it's just a number. Clear. And now we're going to review molar mass, which is a number in grams per mole. So it's the mass of 1 mole of a substance. So the molar mass of gold is how much 1 mole of gold atoms weigh in grams. So another example is the molar mass of water is the mass of 6.02 times 10 to the 23rd water molecules. That value actually is 18.02 grams per mole. And this is basically the molar mass that from water. And if you guys remember, we calculated it 2 lectures ago by summing up the individual atomic masses of each element, and we can use that to find the molar mass. Oh, and here's the H2O example. So, for example, in the molecule water, which has 2 hydrogens and 1 oxygen, we could find the molar mass by doing 2 hydrogens and 1 oxygen. We could do 2 times 1 plus 1 times 16. Remember, we look right here for the molar mass, the atomic mass. And we sum this up so we can get 18, which is close to 18.02. You can get 18.02 by using hydrogen as 1.008 and carrying all the decimal points, but 18 is close enough. So this is the molar mass, 18 AMU, or we can use what we did earlier, grams per mole. So this tells us if we have 1 mole of water, we have 18 grams. So 1 mole of water weighs 18 grams. And we calculated the molar mass from the periodic table. So now the next slide, we're going to do a practice problem relating this. So please type your answer in the chat when you have it. What's the molar mass of hydrochloric acid, or HCl? I'll give some numbers that we can use. We can just assume hydrogen to be 1 and chlorine to be 35.45 to make things a little easier. So we might need a calculator for this. If it's kind of hard, or you can do mental math. Remember, this is basically the same thing as just summing up the individual atomic mass. So good job. Everyone who submitted the answer got it correct. So the first thing we need to see is how many of each type of elements there are. There's 1 hydrogen atom, and then there's 1 chlorine atom. So hydrogen atom has a mass of 1, so it's 1 times 1. And chlorine atom has a mass of 35.45. Remember, the first number tells how many of each elements are in the compound, and the second number gives the weight. So we can just add this up. So this is 1, and this is 35.45. And then we have 36.45 grams per mole. So if we have 1 mole of hydrochloric acid, it weighs 36.45 grams. That's basically what the molar mass tells us. So good job, everyone. Here's another one, H2O2. So please type it in the chat when you finish. So we want to know the molar mass of H2O2. Did anyone have a question? No. Okay, this is pretty similar to the last problem. There's 2 hydrogens, and then there's 2 oxygens. Each hydrogen weighs 1, each oxygen weighs 16. We have 2 times 1 plus 2 times 16, and that gives you 34 grams per mole, which is the right answer. So great job, everyone. So that was our review on molar mass. And now we're going to have to use that molar mass to find the mass of an individual molecule. So we're going to figure out, we know how much 1 mole of the atom weighs. Now we're going to have to try to figure out how much each individual atom weighs. And as you can expect, each individual atom weighs almost nothing. It's really small number, and you'll probably need using the scientific numbers to represent it. So suppose we want to find the mass of 1 gram, mass in grams of 1 chlorine atom. So from the periodic table, we know that the atomic mass is 35.45 grams per mole. So that, and we also have to recall that 1 mole is 6.02 times 10 to the 23rd atoms. So this number, grams per mole, basically tells us 1 mole equals 35 grams. So that's basically what that number tells us. And then remember, we can substitute this. Can everyone please mute? Okay. And then we could substitute this value in, so we can get, so once we substitute this in for the moles, we can get this equation, 35.45 grams equals 6.02 times 10 to the 23rd chlorine atoms. Because in the beginning, we had 1 mole equals 35.45 grams, and we recall that 1 mole is 6.02 times 10 to the 23rd atoms. So we could use like the transitive property of addition of transitive property and deduce that 6.02 times 10 to the 23rd equals 1 mole equals 35.45 grams. This is atoms. Sorry for my bad handwriting. And then we can divide every side by 6.02 times 10 to the 23rd. And if we divide everything by that, we get 1 atom equals, we could ignore the middle part because we were wanting to know the grams. It's basically 35.45 grams over 6.02 times 10 to the 23rd. So that's basically how we find the mass of 1 atom in grams. We basically just take the molar mass and we divide it by 6.02 times 10 to the 23rd. But this is like the derivation that you can see so you can know why it's true. We basically take a molar interpretation of this and just substitute values and do simple arithmetic. So we can just basically divide both sides and we get that the mass of 1 chlorine atom is 5.90 times 10 to the 23rd grams. So that's a really small number. But a shortcut is just basically to divide the atomic mass by 6.02 times 10 to the 23rd, which is the same as Avogadro's number. So that's the special term for this number. And we can get the mass of 1 chlorine atom. So this is example problem. So instead of chlorine, we want to know the mass in grams of one oxygen atom. So that's the example question. You can just use 16 instead of 15.999. And please put your answer, PM me the answer in the chat. You can either use a scientific calculator to get the exact answer, or you can just give me the division, and that works as well. So you can just give the answer as a division. So we want to determine the mass in grams of one oxygen atom. I'm seeing that everyone's kind of confused. Everyone's confused, so I'll just redo the same thing again. So first thing, we need to calculate the molar mass of oxygen. And it's easy for this one since it's just 16 grams per mole. So if we want to do it the long way, we can say, since it's 16 grams per mole, let's assume it has 1 mole. So we have 1 mole equals 16 grams. Of oxygen. But we also know that 1 mole equals 6.02 times 10 to the 23rd atoms. So we know that these two are equal. So then we can, since the left sides are equal, the right sides are equal as well. Whoa, let me equals 16 grams oxygen. So we have 6.02 times 10 to the 23rd atoms is 16 grams. So now we could divide both sides by 6.02. 10 to the 23rd. And we'll be left with 1 atom equals this number. And of course, we can avoid the oxygen. So we know 1 atom is this number, 16 over 6.02 times 10 to the 23rd, which by my calculator show it's 2.66 times 10 to the negative 23rd. So that's how you do it, so to find the mass in grams of 1 atom. So this is a long way. We first use the molar mass definition, 1 mole equals 16 grams. And then we use the definition of a mole. A mole is 6.02 times 10 to the 23rd atoms. And then we combine those two together, and then we divide it by 6.02 times 10 to the 23rd, and then we get the gram of 1 atom. A shortcut, like I said earlier, a shortcut to solving these types of problems is you can just do the molar mass, which is 16, and just divide it by the Avogadro's number. So you can instantly just do this, the molar mass, which is 16, and you just divide it by the number, and then that's always the correct answer. So this is a pretty good shortcut if you need a shortcut to doing it, which is the answer I got. So let's try to do this problem again, and please put your answer in the chat when you get it. The mass in grams of a molecule of HCl. So this is 2 elements, but it's similar. Once you find the molar mass, you do the exact same thing like the last problem. But the molar mass requires the sum of 2 elements this time, and that's the only difference. Oh, whoops, sorry. Let me go back. So is anyone confused about how to do this? If you're confused, can you please write me a message in the chat privately? Because I realize this can be a difficult concept to grasp. Oh, and just to notice, this week, this meeting's going to be 40 minutes and Zoom's going to kick us out. So after it kicks us out, after the meeting's over, can you rejoin the link later on? And we'll continue our lesson if it takes longer than 40 minutes. Okay, I'll go over the solution. Everyone who submitted got it right. So first thing we have to do is find the molar mass. So the molar mass. And we've already calculated it earlier today. It's 36.45. And to find the mass in grams of one molecule, we divide this by the Avogadro's number, which is 6.02 times 10 to the 23rd. So this is the answer that you should have put in the chat. And it's 6.06 times 10 to the negative 23rd grams. So as you can see, it's a very small number. But in the chat, you can put the thing I circled. That's perfectly acceptable if you don't have a calculator. Okay, let me erase. And I'll have one more. So what is the mass of one molecule in grams of methanol? And methanol has a chemical formula CH4O. Okay. So the first thing, as always, is to calculate the molar mass. And as always, we can always use the same abbreviations that we've always used. So there's 1 carbon, so that's 1 times 12. There's 4 hydrogens, 4 times 1, and there's 1 oxygen, 1 times 16. So this sums up to 32. And then we could just divide by Avogadro's number, since we know 32 grams is 6.02 times 10 to the 23rd molecules. So for 1 molecule, we can just divide by that same number. And then if you have a calculator, this is the right answer, 5.31 times 10 to the negative 23rd. So good job for everyone who answered. You got it right. You guys all got it right. Now we're going to do something slightly easier. It's going to be a moles and grams conversion. So we're going to still use the moles, but I'm going to teach you a new method, which is similar to how Art of Problem Solving Introduction to Algebra teaches conversions between units as well. So these mole calculations, we're trying to answer questions like how much does a given number of moles weigh? And if we have a given mass of a substance, how many moles do we have? The reason we care so much about moles is because moles are the way we use in a chemical equation to see the ratio between different reactants and products. So we always want to convert between moles so we can use in our chemical equation, and grams so we can measure it out actually in a lab. So that's the importance of these mole gram calculations. So we can determine so we can actually determine the number of moles and grams we need. So I recommend you use paper and pencil for these problems. And we're going to use a method called dimensional analysis. So molar mass is the important conversion factor between any of these problems. So if you look at a periodic table, you could find that the molar mass of ethanol is, or C2H6O, is 46.1 grams per mole. So from that statement, we know that 1 mole of ethanol is 46.1 grams of ethanol. We can get that directly from this equation. This ratio, sorry, it's not equation, it's a ratio. So if we have 2 moles of ethanol, we can multiply 46.1 times 2. So it's always a ratio. That's what the grams per mole is. It's just a ratio. So if we have 2 moles of ethanol, we would have 46.1 times 2, which is 92.2 grams. And if we have 3 moles of ethanol, then we're going to multiply this number by 3. And that's basically what the molar mass tells us. But from this conversion, we can have 2 conversion factors we can use in a chemical equation. So if we divide both sides by 46.1 grams, of ethanol, and we divide this side by 46.1, notice that, let me erase that. So notice that this left side equals 1 because these two just cancel out, 41.6 grams and 41.6 grams. We're basically dividing it by itself. So we have this equals 1. So we know that this fraction equals 1. 1 mole of ethanol over 46.1 grams of ethanol equals 1. So that's one conversion factor we can use. And since we know that this equals 1, we can reverse and have the reciprocal. And this would just be the exact reciprocal. This fraction is also 1, since that is 1. as we have calculated here. So we can use this and use a bunch of canceling out to solve these problems of converting between moles and grams. So I'm going to actually show you one example of it. So suppose we have 10 grams of ethanol and we wish to determine the number of moles. So to determine the moles, we have to first start with what we have. So we have 10 grams of ethanol. So that's the first thing we put. But then we want to cancel out these grams of ethanol and change it into moles of ethanol. So as you can see, we can use these factors. This factor we just discovered on the last slide that equals 1, we can just multiply it to get our moles. So as you can see, these units, grams, ethanol, cancel, and we're just left with moles of ethanol on the top, which is the exact same unit here. So we're basically trying to cancel out the units. So 10.0 grams divided by 46.1 gives us 0.217 moles. So that's how we basically do grams to mole. We cancel out these factors in red. I'll change it into pink. And then the only unit left is moles on top. So that's the dimensional analysis unit. So that's how we do dimensional analysis. So let's do an example problem. So how many moles are in 5 grams of N2? The molar mass of N2 is 28 grams per mole. So I would recommend using a piece of paper to try to solve these problems. And hopefully use that same method I just showed you on the last slide to try to tackle these problems. And so I see that everyone who submitted got it right. So I'll try to re-explain it for everyone who still doesn't get it yet. So we start off with dimensional analysis with what we have, what the problem statement tells us that we have. So we have 5 grams of N2. So that's what we're going to start out with. So we're going to have 5 grams of N2. And then we want to multiply it by a factor that is equal to 1. And the factor we can multiply it with is the molar mass. Because as we've shown, this factor is always equal to 1. So we want to cancel out the grams and change it to moles. So we're going to multiply it out by 28 grams per 1 mole. And then we see that the units actually cancel out, the grams of N2 and the grams of N2. Since we're multiplying them, we cancel it out. So our answer is 5/28 mole N2. And that's 0.179 moles of N2. So that's how we do it. We basically start out with what the problem tells us. We have 5 grams of N2. And then what we do is use the molar mass, and we try to cancel out the grams from the top of both sides. And then we're just left with moles. And then that's our answer, 5/28. So they're not terribly complicated. It's just one division, basically. So try doing this problem. It's the same thing, except this time they don't give you the molar mass. You're going to have to find the molar mass from these two atomic masses. So when you have the answer, please post your answer in the chat. I'll give you guys a few minutes for this one. give you longer time to try to think it through. So the first step, if you're having trouble, please like type in the chat the first step of the problem, which is what is the molar mass of HCl? Because that's the biggest part about this problem, finding the molar mass of HCl so you can actually calculate grams to moles. Because we need molar mass to do that conversion. So like please type into the chat the molar mass of HCl if you're having stuck and you can't finish this. Okay, that's good. Everyone who answered got it right. So the molar mass, you remember, is just the sum of the atomic mass. So this is 1 and this is 35.45. So the molar mass is 36.45 grams per mole. So this is our important conversion factor. So we start off with grams and we want moles. So we start off with 50 grams HCl. And then we multiply it we want to cancel out the grams of HCl, and we can do it with this number right here. We can multiply it by 36.45 grams of HCl per 1 mole of HCl. And then if you guys notice, this grams HCl cancels with this grams HCl. So we basically get 50 over 36.45 mole HCl. So this is the correct answer. So everyone who submitted that answer, great job. It's fine to submit like 50 over 36 due to slight rounding. And that, if you want the decimal version, it's 1.37. So that's just putting it into the calculator and solving it. So we have one last problem. This one is how many moles are in 45.65 grams of PbCrO4? And I've given you the molar mass of that to be 323 grams per mole. So the molar mass is our friend in converting between moles and grams. So please put your answer in the chat when you get it. This is the magic number right here. I'm pretty sure some of you probably already found the shortcut to this. You don't have to do like the dimensional analysis, canceling off units. I guess you could see the shortcut. Shortcut is basically dividing the grams by the molar mass for this problem. But I always like dimensional analysis because soon stoichiometry gets a little harder. And the way to solve a problem is to just cancel out the units. Okay, so I'll start this problem. So the only information we have other than the molar mass, which would always just be a conversion factor, is we have this 45.6 grams of PbCrO4, which is lead chromate. So 45.6 grams of PbCrO4. But we don't want grams, we want moles. So we could change grams to moles with the molar mass. And we can basically do 1 mole of PbCrO4 is 323 grams. PbCrO4. If we cancel out units, we're left with what we want, moles of PbCrO4. So we can just have the final value of 45.6 over 323. So that's our answer. That's a perfectly acceptable answer. And I know some of you have done the math and got 0.141 moles of PbCrO4. So good job to everyone who submitted. You guys all got the correct answer. So that is very good. I'd just like to mention one other thing today before we leave. We can also go in the reverse direction from moles to grams. So in this case, instead of them starting out with grams, they start out with moles. So we start out with 1.50 moles. We're going to be using the same thing. It's 46.1 grams per mole. And if we use stoichiometry, we can solve the problem the same way. So we start off with what we have, which is 1.50 moles. C2H6O. But we don't want moles, we want grams. So we can multiply by our conversion factor. This time 46.1 is on the top. Because we want moles to cancel out. So as you can see down here, this time we're multiplying by our free unit, which equals 1 at all times. We're putting the 46.1 at the top this time, because if we do so, the moles would cancel out. And then we're left with grams, which is what we wanted. So we can do that little calculation, 46.1 times 1.5. And if we do it out, it's 69.2 grams. So this one won't be on our homework this week because I just wanted you to go one way. But notice that we could also go in the reverse direction. And our magic friend is always the molar mass. And if you don't know the molar mass, you can always look it up in the periodic table. You could just see the individual mass for this carbon, hydrogen, and oxygen, and just sum it up, and you'll get 46.1. And that's how we get this magical number to do our calculations. So that's why molar mass is so important. It gets us from moles to grams and grams to moles. Okay, for all of you who weren't here earlier when I talked about this earlier, I created a suggestion/improvement form regarding this class on Google Classroom. So it's not just this lecture, but this whole series of classes as a whole. I'd want like suggestions to see how I could improve, and if there's enough interest for like a second part 2 of this introductory high school class. And you'll have the option of telling me what you'd like me to change, what I could do better, and things that you like about this class. It's under the classroom tab in the Google Classroom, and there are 7 questions, and they're relatively short. Some of them are like ranking how hard the class was, etc. And it should take no more than 4 minutes of your time. And I would appreciate it if you could fill out the form by next week, so I'll fully know the results of the class. And today, we reviewed the moles and molar mass, and we learned how molar mass is important in the conversion between moles and grams. And we found the mass of an individual molecule. So as a recap, to find the mass of an individual molecule, you basically take the molar mass and you divide it by Avogadro's number. So if the molar mass, which I'll abbreviate MM, is like 16 grams per mole. Remember, 1 mole is just 6.02 times 10 to the 23rd. So 1 atom. So this is just 16 over 6.02 times 10 to the 23rd. I just realized while teaching, an easier way to see this is recall that the molar mass is 16 grams per 1 mole. We can just change out the moles with 6.02 times 10 to the 23rd atoms, and we'll immediately get our answer. So that's how we find the mass of an individual molecule. So for homework, there's 2 of these questions. There's 2 molar mass questions. And then the last one, moles and gram conversion, it's basically, there's going to be 2 of these as well. And they're going to be the exact same way as we've done it in class. I give you grams, and I want you to get grams to moles. And the way to get grams to moles is always using our handy molar mass, and use dimensional analysis to help cancel out units. So we want grams always to be the bottom when we start out with grams, and if we start out with moles, we want the moles to be in the bottom. And it's just a 1 step. But in the homework, the answer choices are going to be in decimal form, so you can't leave it as a fraction. And then there's 6 questions, and I gave you the brief overview of how many types of each questions there are in the Google Classroom tabs. And if you have any questions, please contact me at this email. Thank you for attending class, everyone. And that's it.